For today's enrichment lesson, we're going to continue talking about data analysis, specifically kind of analyzing graphs and seeing what that can tell us, as well as some biases when you're collecting data. So as we've kind of talked about, the center of data is giving us values in the middle of the data. So specifically things that we look at are like mean and median. The spread of the data, that's how either close together it is or spread out it is. We are looking at things like range, IQR, or MAD when we're talking about how spread it is. And then shape of the data, that's what we're going to look at right now. Shape, we can look at specifically with graphs, how it's shaped. That can tell us how it is distributed, how spread out it is. So specifically, we're going to be looking at three types. We have symmetrical, skewed right, and skewed left. So symmetrical, that means maybe not perfect, but generally speaking, if we were to split this thing in half, the left side looks identical, just kind of flipped around to the right side. It's balanced on both sides. Same thing here. We have it split in the middle. The left side, I'm going to highlight that to make it easier to look at. The left side and the right side look pretty identical. For this, your mean and median are the same or at least very close to each other. Then we have skewed right and skewed left. So we got to be careful with this because for me, it kind of seems opposite. I think of skewed right, there's going to be a lot of data at the right, but that's not what it is. So when a graph is skewed right, there is a long tail on the right because there is less data. So skewed right, what we're looking at here is less data on the right. For skewed left, less data, whoopsies, you can't see that, less data on the left. Okay, so for skewed right, if we're kind of splitting this in half, there's less data on the right. Skewed right and it's more spread out. For dot plots and bar graphs, they have less data on the right, which actually means for box plots that it's spread out on the right. So when we split it in half at that median, it is spread out. So this is less data here, but it's spread out in a box plot. So for skewed left, again, if we're splitting it in half, for this bar graph here and dot plots, we're going to see less data on the left. But when we're looking at a box plot, we will see it more spread out on the left. Okay. When you have something that's skewed right, the mean is greater than the median. When it's skewed left, the mean is less than the median. So let's look at just being able to determine whether it's skewed right or left. And I would encourage using this, having this open so you can look at it, knowing those details that are highlighted here. So determine whether the following data sets are symmetrical, skewed right, or skewed left. So we've got three similar scenarios. Here we have our dot plots. So in the dot plot, if it's skewed right for a dot plot, there is less data on the right. If it's skewed left, there's less data on the left. So when I split these in half, or close to it at least, split this in half, less data here. Split this in half, less data here. So this one, the first one has less data on the right, so it's skewed right. This one has less data on the left, so it's skewed left. This one has less data on the left, so it's skewed left. All right, next ones we're looking at box plot. Remember that box plots work the opposite way, kind of. So a box plot, if the graph is more spread out on the right, it is skewed right. If it's more spread out on the left, it's skewed left. So let's look at these three examples. Remember, the line in the middle of the box is our halfway point. So I'm just going to kind of draw a line through there, and we can figure out. So for this one, it looks pretty symmetrical to me. The left side and the right side look the same. So I'm going to say symmetrical. Here, it looks a little bit symmetrical, but if we look, this range on the left seems bigger. It seems more spread out on the left. So I'm going to say skewed left. And then over here, again, it looks like there's more data on the left. It's spread out more, so skewed left. Last one, we're looking at bar graphs. Bar graphs work the same as the first three that we did, the dot plots. So when a graph is, if there's less data on the right, it's skewed right. If there's less data on the left, it's skewed left. So I'm going to just kind of guess the midway point. Here, there is less data on the left, so that is skewed left. This one, it looks pretty identical on both sides, so I'm going to say symmetrical. And over here, there is less data on the right side, so that is skewed right. All right, so that's the first part of this enrichment. The next part is looking at different biases, okay? So samples, when we're surveying people, when we're trying to gather information, we're not gonna be able to ask every single person. So for example, if I'm surveying doctors to see, or dentists to see if they like certain toothpaste, I'm not asking every single dentist, I'm taking a smaller sample. So samples are the actual part of a population that is being surveyed. An unbiased sample is a sample selected so that it accurately represents the population. So what that means is that it's true. It's a good representation of the population. There are two types of unbiased samples. We have a simple random sample, which is a sample where each item or person in the population is as likely to be chosen as another. So that means like you're rolling the dice, you're picking names out of a hat. It's a random way that you are picking people. The other unbiased sample is a systematic random sample. So this is a sample where the items or people are selected according to a specific item or time interval. So that means like maybe I'm testing out the chocolates at the Hershey Chocolate Factory. I'm going to test every 10th chocolate that comes through on the assembly line. Or I'm going to test a chocolate every 5 minutes. So I've got some type of interval going. Then we have biased samples that don't really accurately represent the population. So this is a sample where one or more parts of the population are favored over others. The two types that we're going to look at are convenient sample, which is a sample that consists of members of a population that are easily accessed. So for example, if I wanted to find out the average height of students in Middle South, but I only asked our sixth grade class, that's not representative of the whole population, because sixth graders are probably shorter than seventh and eighth graders. But that was convenient for me. It was easy for me. I was being lazy. The other example is voluntary response sample, which is a sample that consists of only those who are volunteering, makes sense, like the name, to participate. So if there's a voting booth, or you're saying, hey, please participate in this, and they're choosing to do it, that's a voluntary response sample. Or if you think of like Yelp reviews of restaurants, those are people volunteering to respond, and it's biased because a lot of times you either have really good reviews or really bad reviews. It's not every single person reviewing the restaurant. So let's look at these examples to see if we can pick out what type of sample. So determine whether each sample is biased or unbiased and explain why. Specify the type of sample it would be. So number one, Geronimo is trying to determine Hawthorne Middle South students' favorite TV show. He randomly surveyed people during all lunch periods. So he's trying to determine for Hawthorne Middle South, he did it during all lunch periods, which would be all students. And he randomly surveyed. So we know that this is unbiased. This would be fair. He's not just picking a convenient population. If he's randomly surveying, that's going to be the simple random sample. Number two, to find out how much money the average American family spends to cool their homes, 100 Alaskan families are surveyed at random. So we want to know how much money the average American, so all over the United States, from Florida to Hawaii to New York to Illinois, spends to cool their home. They surveyed 100 Alaskan families. First of all, that's only one state out of 50, and if we're talking about cooling their homes, Alaska's probably a different story there, because they're not looking to cool their homes. They're probably looking to heat them in more so throughout the year. So this is biased. This isn't going to be an accurate representation. And what we would consider this, because when it's biased, it's either convenient or voluntary. They're not volunteering to respond. This is just convenient. This is just being lazy and just asking one state. So convenient sample. Or number three, to evaluate the quality of their product, a manufacturer of cell phones checks every 50th phone off the assembly line. So when we are doing something at an item interval that is unbiased, that is a fair representation, and since we're just doing every 50th phone, that's the item interval. That's a systematic random sample. And last one, a magazine asks its readers to complete and return a questionnaire about popular television actors. So a questionnaire, and they're asking them, that is someone that is volunteering. So it's an optional thing. They do not have to do it, which means it is biased. And specifically, when it's optional, they can choose, they can volunteer to participate. That's the voluntary response sample. And that is it.